This is Geometry Lesson 3.2, which is Properties of Parallel Lines. So just to review what we talked about in 3.1, when you have lines that are cut by a transversal, so for example, in these pictures, you have, in each of them, lines that are cut by a transversal. There's 8 angles that are formed, and there's relationships between the different kinds of angles. So, of course, we still have vertical, like angle 1 and angle 3 are vertical angles. That's something we talked about in the last chapter. And we still have linear pairs, which, for example, 2 and 3 are linear pairs because they're adjacent and supplementary, forming a line. And then there's some new angles that are formed. So for this example, you don't have to have parallel lines. Just have any two lines in a plane cut by another line that's in the same plane that's hitting it in different points, hitting the lines in different points. So the different kind of angles that are formed, we have interior angles and exterior angles. The alternate interiors are ones that are on opposite sides of the transversal, but still between the two lines. So they're interior angles, but they're on opposite sides of the transversal. And they're not linear pairs, so non-adjacent, not linear pairs. Then you have same side interior. Some books call them consecutive interior, so you can refer to them as either. And consecutive interior or same side interior are ones that are interior angles. They're between the two lines, but this time they're on the same side of the transversal. Then you have corresponding, which basically mean they're kind of in the same position. So like angle 1 and angle 5 are both sort of the northwest corner of their little respective neighborhoods. So they're both above their lines and on the same side of the transversal. And then next ones are alternate exterior. So alternate exterior, they're outside of the two lines, that's what makes them exterior, and they're on opposite sides of the transversal, which is what makes them alternate. Now remember, there's also consecutive exterior that are not listed on this picture. Consecutive exterior would be like, let me make a drawing here. Consecutive or same side exterior would be like angle 2 and angle 7. So they're exterior because they're outside the two lines, but they're on the same side of the transversal. Okay, now when the lines are parallel, we actually have some additional properties that we can refer to that we can assign to the different kinds of angles. So if you were given that the measure of angle 1 was 60 degrees, I want you to make sure you know that the notation that says line M is parallel to line T. And the way that you show that on the picture is to put little kind of like triangles on or little arrows on the lines there. If you had another pair of lines that were parallel, you would put 2 little triangles on them if they were in the same diagram. Okay, so if you knew that angle 1 was 60 degrees, then you could say, okay, angle 3 has to be 60 because why? Well, they're vertical angles, so they're congruent. How would we know the measure of angle 2? Well, 1 and 2 are a linear pair, so they're supplementary, making them have to add to 180. Likewise, angle 4 would also add to 180 degrees. So angle 4's measure would also be 120. And then if we kind of assumed, because we sort of have to assume some things, and one thing that you're allowed to assume is that when you jump from one picture, one little corner of the diagram here, down to the other corner, what kind of angles are those? Well, those are corresponding. And most books assume that the corresponding angles will be congruent to each other and make that their postulate. Your book does not use corresponding angles to be the postulate. It uses same side interior to be the postulate. But basically, you have to have some basic assumptions that you can use then to develop and prove other things from. So if we assumed that these corresponding angles were congruent, which completely makes sense, that if the lines are parallel, the transversal would cut them sort of at the same angle, then we could also work our way around the bottom. So the vertical angle here would be 60. The linear pairs would have to be 120, would make the rest of these 120 degrees, and then you could have some angles to look at. Now, this is not a proof, this is just sort of a demonstration. If you have parallel lines that are cut by a transversal, then corresponding angles are congruent. So like, for example, angle 1 is congruent to angle 5. The way you would write that is that if, let me get rid of that for a minute here. The way you would write that is if lines are parallel, then corresponding angles are congruent. So that would be like angle 1 is congruent to angle 5. Likewise, alternate interior. So corresponding pairs are congruent. Alternate interior, how are they related? Well, for example, angle 3 and angle 5 are congruent. They're alternate interior. Same side interior. Same side interior would be like these two angles, angle 4 and angle 5. They are not congruent, they are supplementary. They're going to add to 180 degrees. Are they a linear pair? No, because they're not adjacent, but they are supplementary. Okay, and then alternate exterior. Let's see, how about like angle 2 and angle 8 would be congruent because they're alternate exterior angles and the lines are parallel. And then note that there is another pair of angles that are not listed there that I'm okay with you referring to. The same side or the consecutive exterior angles. Consecutive exterior would be like angle 2 and angle 7. Same side of the transversal, outside of the two lines. How are they related? They're going to be supplementary. So notice that most of the angle pairs are congruent, except for the ones that are same side interior and same side exterior, or consecutive interior, consecutive exterior pairs are supplementary. Obviously, linear pairs are also supplementary. Vertical angles are congruent. Those don't rely on parallel lines, but these are the new properties that you should know about parallel lines. Okay, so just for reference, I have this copied again up here, just so we have this to look at when I'm going through this next example. So, again, same side interior supplementary, same side exterior supplementary, and then the other ones are all congruent. So, corresponding are congruent, alternate interior congruent, alternate exterior congruent when there's parallel lines cut by transversal. Okay, so in this next picture, you're shown on the diagram that the lines are parallel because they've got the little triangles there showing that. Why is angle 3 congruent to angle 7? We're going to write a statement that would justify why that's true. Okay, so how are 3 and 7 related? Well, those are corresponding angles because they're in the same position. Okay, so corresponding angles should be congruent because if lines are parallel, then corresponding angles are congruent. That's what justifies why angle 3 and 7 are congruent. Okay, angle 3 and angle 6, how are they related? They're alternate interior. How are alternate interior angles related when the lines are parallel? Again, referring up there, this should make sense, but just while you're getting used to it, you can use that little chart. Those are congruent because if lines are parallel, then alternate interior angles are congruent. Okay, how about 2 and 7? 2 and 7 are alternate exterior. Why are they congruent? Well, because if lines are parallel, then alternate exterior angles are congruent. And then lastly, measure 4 plus measure 6 is 180. Well, why is that true? 4 and 6 are what kind of angles? They're between the lines, so they're interior. They're on the same side of the transversal, so they're same side interior or consecutive interior. So if lines are parallel, then consecutive, or you can call them same side interior angles, are supplementary. They're not congruent, they're supplementary. And again, be careful, those are not a linear pair because they're not adjacent to each other. So they are supplementary. That's how you justify. When it says justify using a postulator theorem, that's a justification. All right, in the next problems, we're going to be solving for x and y. And so we're going to make equations and then write the statements that explain why that's true. So for the first one, okay, this angle and this angle. Now again, notice that you're shown on the picture that the lines are parallel. If the lines aren't parallel, you don't have all those relationships. Okay, so parallel lines is what will give us what we need. Okay, so these are corresponding angles. So you would say if lines are parallel, then corresponding angles are congruent. So to solve for x, we'd say 3 times the quantity x plus 9 is equal to 129, which makes 3x plus 27 equal to 129. So 3x is 102, and x would be 34. So 34 is the value that would cause that angle to be the same as its corresponding angle, which is 129. All right, next problem. How are these angles related to each other? Well, they're alternate interior. If parallel lines are cut by a transversal, then alternate interior angles are congruent. So we're going to also make those equal. 80 is equal to 5x minus 15. 95 equals 5x. X is 19. Okay, next problem. Well, how are, a couple different ways you could do this. How are these two related? Well, linear pairs are supplementary. That's a postulate from before. It's called the linear pair postulate. If you want to call it linear pair postulate instead of writing linear pair supplementary, that's fine. 98 plus x is equal to 180, and that would make x equal to 82. All right, and then we've got, if that's 82, then we can say that y is also 82, because if lines are parallel, we'll write if then form. If lines are parallel, then alternate exterior angles are congruent. You could also use, for example, that 98 and y add to 180 because they're consecutive exterior and they're supplementary. So whichever way you want to do it is fine. Okay, and then lastly, in this group, how are these angles related to each other? Well, they're between the two lines and they're on the same side of the transversal. So those are consecutive interior or same side interior. If lines are parallel, then same side interior angles are related how? They're supplementary. Hopefully looking at that, they don't appear to be congruent, right? So even though I usually say don't go by how it looks, you kind of can go by how it looks on these problems if they're drawn correctly, drawn well. Okay, so 75 plus 4x minus 9 equals 180. 75 minus 9 would be 66. Plus 4x is 180. 4x equals 114. I think that's right. And then that makes x 28.5. Okay, so it says solve for x and y, and then the statements, the postulates or theorems, that's like your justification that explains why your equation makes sense. All right, now we're going to also do some proofs because proofs are fun and we love proofs. Basically, this is just kind of giving you some practice on what you can do to justify why, what kind of reasons you've got going on in a problem. So in this diagram, we're given that this angle measures 105 degrees. So even though this isn't actually stated as a given, it's shown on the picture, so that's really your given. And it says we're supposed to be figuring out what the measure of angle 1 is. Okay, so angle 1 is congruent to angle 4. That's really not given. Why is that? Okay, we were given that the lines are parallel. Again, you can tell on the picture here, they've shown you the parallel lines there. So angle 1 is congruent to angle 4 is if lines are parallel, then what kind of angles are those? Those are alternate interior angles are congruent. Okay, why is the measure of angle 1 equal to the measure of angle 4? Well, that's not a new reason, right? That's the definition of congruent angles. We know that from last chapter. 4 and 6 are supplementary. When you look at the picture and you go, okay, look, 4 and 6 are supplementary angles. Why are they supplementary angles? Because they're a linear pair. This is a linear pair postulate. Linear pairs are supplementary. Okay, if they're supplementary, why did they add to 180? Well, that's the meaning of the word supplementary, so that's definition of supplementary angles, or just definition of supplementary. Okay, so we basically used 1 to get 2. We didn't really use 2 yet. We got 3 from the diagram, we used it to get 4. So on our step 5 here, we really have statement 2 and statement 4 that we're going to use to get statement 5. So what happened there? Angle 4 got replaced with angle 1. Why are you allowed to do that? Because they're equal. So what's the reason? Substitution. Could that one be transitive? Well, no, because you didn't wipe out a whole side. You just replaced one term in the equation number 4. So we use 2 and 4 to get 5. Now, measure of angle 5 is 105 degrees. While that's true, that has nothing to do with the rest of this proof. So I'm going to completely ignore that step right there because we did not need that in the slightest in order to be able to do this problem. So I'm just going to get rid of it. Gone. Okay, measure of angle 6 is 105. Well, what kind of angles are those? If lines are parallel, then what kind of angles are those? Those are alternate interior. Angle 6 and the 105 are alternate interior angles. So they would be congruent. Okay, what's happening in number 8? Well, we basically said since the measure of angle 6 is 105, we could take that, plug it in right there in place of measure of angle 6, and we'll have the equation that we were trying to end up with. So that one's substitution. Also not transitive, just replacing one term. And then what's going on in the last step? Well, we just said, all right, let's subtract 105 from both sides and solve for the measure of angle 1. So that would be subtraction, property of equality. Now, when you look at the picture, do you really have to go through all that justifying to figure out angle measures? No, you don't. Like, you don't have to write all those steps down in your head. You should be saying to yourself, okay, why does this make sense? Okay, I'm trying to find angle 1. Well, 7, they're going through a linear pair here, but we could say like 7 and 5 and 105 are the same. Okay, I don't even need angle 7. I don't know why I said angle 7. Okay, so we could say we're trying to get to angle 1. The 105-degree angle and angle 4 are linear pairs, so they're supplementary. And then 1 and 4 are congruent, so that'll make the measure of angle 175. There's like other ways to get there besides the way that they just did this proof. Okay, you could do 105 and 3 are congruent because they're alternate interior, and then you could do 3 and 1 are supplementary because they're consecutive exterior, so therefore it's 75. And then one last proof, because we love proofs so much. Okay, so given angle A is parallel to angle B, prove angle 1 and 7 would be congruent. We're basically proving the theorem that says that if parallel lines cut by transversal, then alternate exterior angles are congruent. So given A is parallel to B, what are we trying to prove? We're trying to prove angle 1 is congruent to angle 7. Okay, if lines are parallel, then corresponding angles are congruent. Well, where are their corresponding angles in the picture? We got angle 1 and angle 5. Angle 1 is congruent to angle 5. So angle 1 is congruent to angle 5. And then how are we going to link together step 2 and step 3 to make angle 1 congruent to angle 7? Well, you can see it's got vertical angles are congruent. They really didn't even have to give you that because we're pretty good. We don't really need to be told that, but they kind of give you that hint there. So they're saying we're going to use vertical angles. The only vertical angles there that are numbered are angle 5 and angle 7. And then we knew we were supposed to use transitive, so that makes sense. We've got angle 1 is congruent to angle 5, angle 5 is congruent to angle 7, therefore angle 1 is congruent to angle 7. And this is the end of lesson 3.2 on parallel lines and their properties.